All right, welcome everyone. Let's get right into it. Today, we're going to have a strategic discussion about the state of artificial intelligence. The goal here is to cut through the hype and get right to the core of what AI is, where it's actually heading, and what it really means for us as professionals in this space.
You have to start at the beginning. This right here, this is the origin story. A 1956 conference at Dartmouth, and a statement that was, let's be honest, less of a technical spec and more of a philosophical moonshot. The ambition was just breathtaking, to simulate every single facet of human intelligence.
So that really tees up the big question for our briefing today. After all these decades of research, billions in investment, and countless breakthroughs, how close are we really to that original grand vision? And maybe more importantly, what does the road ahead look like?
Okay, so let's start by getting our feet on solid ground. We need a clear, shared picture of the current AI landscape as it exists right now.
The 2023 AI Index report from Stanford gives us a fascinating snapshot, and what's really striking is the tension in the field. First off, industry is just racing ahead of academia in developing new models. The implication there? Well, the research agenda is being set more and more by corporate priorities. We're also kind of hitting a ceiling on our traditional benchmarks, which tells us we need new, smarter ways to even measure progress. And then you've got this paradox with AI's environmental impact. It's somehow both a solution and a major problem. On the human side of things, we're seeing a huge spike in AI misuse, but at the same time, a massive, soaring demand for AI skills. And while private investment actually cooled off for the first time in a decade, governments are leaning in more than ever. It's a field in flux, absolutely full of contradictions.
Now, just to make sure we're all working from the same playbook for this discussion, let's quickly break down the core philosophies that have really shaped AI since day one.
This matrix is a fantastic way to understand the four main schools of thought. So in the top left, you've got thinking humanly. This is the cognitive science approach. It asks, can we build a machine that thinks like a person? With all its messy biases and shortcuts. Then to the right, thinking rationally. This is all about pure, cold logic. Can we make a system that follows the formal laws of thought to get a provably correct answer? Think of it as the Spock of AI. Then on the bottom row, we shift from thinking to doing. Acting humanly is basically the Turing test. Can a machine act in a way that's totally indistinguishable from a person? And finally, acting rationally. This is where most of the action is today. The goal here isn't to be human-like, it's to be optimal, to make the absolute best decision to achieve a goal.
Okay, so now that we're aligned on the fundamentals, let's open up the modern AI toolkit. These are the key capabilities that are really driving the revolution we're seeing today.
First up, computer vision. This is the eyes of AI. It's the tech that lets machines make sense of the visual world, to see and interpret images, to understand what's happening in a video, and to identify all the objects and people within them.
So how do we actually teach a machine to see? Well, it's basically a three-step process. First, you feed a neural network a gigantic data set of labeled images. We're talking millions of pictures of cats, for instance. Then, you train that network to recognize the patterns that define what a cat is. And finally, you unleash that trained network on new images it's never seen before, and now it can identify and classify objects with incredible accuracy. It's really that simple at its core: data, training, prediction.
Next up is natural language processing, or NLP. This is the voice and ears of AI. NLP is what lets machines understand our messy human language, figure out what we mean, and then generate coherent, context-aware language of their own. And at the very heart of all of this is machine learning. Think of it as the brain of AI. Instead of painstakingly programming a machine with rules for every possible scenario, we just train it on massive amounts of data and let it learn the patterns to make its own predictions. This is the engine that powers the entire modern AI revolution.
So, we have the tools, right? The eyes, the ears, the brain. The critical question now is, how do we apply them strategically? That's where you need a framework.
The AI marketing canvas is a perfect example of a strategic framework. And look, even though it says marketing, these principles of phased adoption can be applied to almost any part of a business. It gives us a really clear 5-stage roadmap.
So let's walk through these 5 stages. It all starts with the foundation. You have to get your data in order. AI is absolutely nothing without clean, structured data. Then you move to experimentation, where you test specific AI tools on high-impact problems. Once you find what works, you expand, broadening the use of AI across the organization.
Transformation is that next crucial step. You stop just being a consumer of AI tools and you start building your own in-house capabilities. And finally, you hit monetization, where you're actually creating brand new revenue streams directly from your AI.
And we can see this in the real world. For experimentation, just think about Spotify's personalized playlists. That's a super targeted use of AI to solve one problem and make the user experience better. For transformation, look no further than Netflix. AI isn't just a feature for them, it is the absolute core of their business, personalizing everything from the shows you see to the thumbnail artwork they show you. And for monetization, Amazon is the classic example. Their recommendation engine, that's not just a nice little feature. It directly drives a massive chunk of their sales. And we're seeing this kind of impact pretty much everywhere. I mean, just take conversational AI in customer relationship management. It's dramatically improving the customer experience, it's making everything more efficient, giving you 24/7 availability, and yeah, it's driving sales. It's a clear win-win, creating real, tangible value.
Okay, so up until now, we've mostly talked about how to apply AI to problems we already know. But what about the unknown? What about the problems where we don't even know what the best solution looks like? That's where we get to a new and pretty fascinating approach.
Think of it this way. Traditional optimization is like climbing a mountain. You have a map, you know exactly where the peak is, and you follow a calculated path to get there. Evolutionary computing, on the other hand, that's like exploring a brand new continent. You don't have a map, you have no idea where the highest point is, you have to find your way by just exploring. Instead of looking for one single perfect solution, you're evolving a whole population of possibilities to see which ones survive.
And believe it or not, this is not a new idea. It's been around for decades, and its roots go all the way back to Darwin. But today, it's more relevant than ever. We're using it to solve some of the most complex problems in AI, like designing the very architectures of our deep learning models.
To really see how this works, let's use a quick story. Go back in time to pre-industrial England. The peppered moths there were mostly this pale, speckled color, which was perfect camouflage against the lichen on the trees. They were beautifully, perfectly adapted to their world.
But then, everything changed. The Industrial Revolution kicks in, fills the air with soot, and turns all the trees black. All of a sudden, those light-colored moths were easy pickings for birds, while the rare, dark-colored moths were perfectly hidden. And so, just through the relentless pressure of survival, the entire population of moths evolved to become dark. The environment changed, and so did the optimal solution.
And here's the incredible part. There was no grand plan. There was no guiding force. Nobody told the moths to change color. It just happened. It was a result of random variation and the inescapable pressures of the environment. The solution emerged from the system itself. And that is exactly how these evolutionary algorithms work.
And that really brings us to our final and I think most crucial question. We have spent decades teaching AI to solve problems we already understand, to optimize the known world. But what if we could teach it to solve the problems we don't? What if we could teach it to explore the unknown, to discover solutions we haven't even imagined, and to push the boundaries of what we all believe is possible? That's the promise of this next frontier, and it may very well be the future of AI. Thank you.